be using different systems. And there is a need actually to identify some, you have to consider some deployment scenarios, and then how you can try to identify some use case, some potential misuse cases which can be result in a cyber attacks that will have an impact on the smart grid system as well as on the society in terms of this. And we did this study basically is partly under the Norwegian project here, which is going with the Norwegian government and research partners that involves academia, industry, research institute. And basically in Norway, what we have so far is basically, so basically we have a system with a large hydro power plant that basically generates electricity, and that is being transmitted to the every household. But this has been changing nowadays. Now, instead of a large hydropower plant, now we have a tiny small power plants which actually produce the energy, and that is being integrated with the TSO system. At the same time, now we also have a solar power as a flexible resources at the same time, as you see on the right side picture. So we also have solar grids as well. At the same time, we also coming to us. So we don't have a microgrid, at least in Norway so far, but also we have electric vehicles at the same time. Now, integrating all those systems definitely going to have some kind of impact in future in terms of control. And now we try to see what exactly we try to see now, at least in Norwegian system, what kind of attack we will see in next 10 years. And the focus in our paper is basically on misuse cases, and we try to define those misuse cases in a fashion. Basically, now every system will have some kind of security threats. At the same time, we will also have some vulnerabilities that can be exploited in practice, and those will be misused. Misuse means attacker will gain something out of it. Either it may, because attacker incentive might be to make some disturbance, for example, to the existing system. That may be his motive. Maybe he's getting paid for that, doing this bad activity, or it could be a nation state actor, assuming that the cyber world war, the cyber kind of scenarios is changing nowadays, which nation state actors are interested about attacking other governments, for example, that we have seen some conflicts in some countries, that countries' ICT infrastructure is getting attacked. I mean, we already know the case of Estonia, where their IT system was completely attacked by the nation states actor, and that resulted in all the services were down, basically. I mean, and this kind of scenario may happen in future as well. So it's becoming critical infrastructure part. So we try to focus on those misuse cases, which may result with some impact, and then that needs to be tackled or addressed, at least to see that we need to identify those misuse cases. And particularly when we look at these misuse cases, we also try to focus on 3 parameters, or at least 3 aspects of future smart grid in terms of a definition of a smart grid. And the first one is integration of flexible resources. And in terms of Norway, the flexible resources could be a solar power or small hydropower plants. At the same time, electrical vehicles or electrical battery storage units in future, that may increase a lot, because already in Norway there are plenty of electric cars. Actually, it's more than 50% in last 3 years. That has been growing a lot. And actually, how to integrate those flexible resources which are bidirectional. Bidirectional, it means that we no longer have like a one centralized power generation unit which is producing the energy and transmitting to every household. Now, actually, even the end user is kind of producing his own energy by using power plants, solar power panels, for example, and also feeding to the TSO system at the same time. And now, how do we, I mean, in terms of this integration, what can go wrong, for example, of having those flexible resources? At the same time, the smart distribution grid, that needs to have a power of monitoring and control capabilities, because when you integrate this ICT and OT component, you need to have this highly efficient monitoring and control capabilities so that the grid stability should be maintained. And what can be impact it have on the grid stability to avoid the blackouts in the worst case scenarios, and how to monitor this effectively. And third is about microgrids, because that's kind of a emerging area nowadays. We are saying that microgrids could be interesting factors for future. I mean, in many countries, people are already seeing that, but we also try to focus. And in Norway right now, we don't have it so much microgrids or concept in the current system, but in future it may have it. So we try to identify all the misuse cases in all these three scenarios, and then we try to stick with those components. And the research method we try to utilize for this, first of all, we focus on the qualitative research approach, in which basically we arrange some workshop with industry participants in Norway that involves the TSO, DSO, at the same time government organizations, some research institute which are working in this area at the same time, and academic researchers. But based on this, in this workshop, we also discuss with power system researchers. So only the researchers who are focusing on TSO-DSO interaction. TSO means, transmission system operator, or distribution is basically distribution system operator. And at the same time, who are working on distribution grids or microgrids, for example, and we try to had a discussion with them what can be in future looks like the scenarios of ICT and OT components and interaction. We also did literature review about the cyber attacks in power grids. So what kind of cyber attacks has been discussed in the academia so far, or at least in the peer review publications. And then people try to see that they may have impact in future or existing current systems. And at the same time, we also did the validation of our findings, like we identified the use cases. These are the misuse cases. This may have impact. We describe them, what they looks like and what could be the impact. And we did the validation of our findings with the DSO. At the same time, one vendor who is providing electricity, who is the energy supplied in Norway. And we try to validate those findings, and we confirm that this may have a problem, for example. So this is basically the whole methodology we have been using this research paper. Then now going back to the misuse cases, as I said, we focus on three ones. And now let's try to see some of the examples we have been doing with integration of flexible resources. And we tried to give some examples in this presentation, but I think the whole list of plenty of use cases you will see in the research paper. Due to the time constraint, we try to highlight only few important words which can convey the message out of this research, or at least they highlight our objectives. The first is about, of course, we're going to have a flexible resources in future, but when you look at this communication of this control signals for flexible resources, because all these flexible resources will be distributed, at the same time, the kind of information which has to be transmitted from these flexible resources is kind of an important factor. And we see that attacker may try to disturb the grid stability by hijacking control signals to the flexible resources. And so one of the examples we try to give basically, there could be a threat actor who gains access to the communication network used for sending these control messages to or from the flexible resources. And this could be like a remote terminal unit, which is we use in RTU, for example. In future, those RTU right now, they are being connected with a wired line or with a power signal, but in future, they may be wireless as well. And the attacker may try to get control over those RTUs. We have seen some examples in research where RTUs are exposed over the internet, for example, or with internet connectivity, and they may get attacked over the internet as well. And hijacking those control signals may have some impact, because the flexible resources may send some readings to the command and control operation center that can be changed, altered, because if there is no integrity protection, and that may have some consequences. Also, threat actor can observe the communication until he's able to understand the kind of format, or it could be encrypted format or some kind of a pattern, and try to understand the control signals, what they are giving. There could be a replay of those messages, for example, and then that's kind of important to maintain the grid stability in that context. Also, he can try to modify the message at the same time, or create his own fake messages to just disturb the system. Or, of course, goal is to destabilize the grid in that context. This is the first one. Then we also look at the attacks, which may be originating from the flexible resources. So it could be that one of the power plant or the solar power plant may be actually be compromised, which is connected to internet. And basically, if you compromise those IT components of those device, I mean, attacker can also control and try to send the fake data or try to create different spike, which may have impact the power demand and response and try to destabilize the grid in some sense. So that may be possible. We have also seen one research paper which basically talk about if you have a malware installed on your laptop or even in your office PCs actually, so this malware can also be tried to change the readings or what do you say? I mean, so this research paper was talking about if you have a malware actually that can drain some battery, not substantially, but they try to think of a botnet which is controlled botnet, which is basically created to create a spike of a power actually demand and supply in the night, for example. So that can make some load changing attacks. And this paper did some simulation. So we try to take this reference and try to see in future this may be possible because we will have a more IT devices connected in future, which requires power, and then they can have a malware installed, for example, and then this can be a threat as well. Then the compromising the restoration functionality, because in our power grid, of course, the restoration is the point where this is the balancing act of restoring enough energy production before applying the load or not applying too much load. So this has to be restoration. And the same paper also talks about actually the coordinated load changing attacks can have a impact at the same time. And this paper, where they did a simulation, they tried to see that actually power can be lost for the whole country if you've been successful of those attacks. And it's possible to also that the threat actor can gain access to the communication network between TSO and DSO, and that may have a huge impact because you can really manipulate the data going between TSO and DSO as long as you're not being properly protected. Of course, there are different standards which are being used, how TSO, DSO should speak to each other with the different IEC standards for the communication, which lacks some kind of a security in the sense that end-to-end security model, and that can have impact as well. Then going back to the second case, which is the smart distribution grid. And here basically, with the smart distribution grid, it's about the first we try to describe some use cases on related to state estimation. State estimation means there could be different instances where attacker can try to inject false measurement data. It means that if we compromise a substation, for example, which is not being protected properly, and nowadays we are seeing that some companies are trying to build a new substation with a combination of ICT and OT technologies, which can be connected over the internet. And what if the attacker actually get access to this power substation and by through malware instance or attacking over the internet? There could be different instances this can be attacked. At the same time, there could be different sensors in the power substation that can feeding data to the command and control system. And attacker can try to fiddle with that sensors, try to confuse the state estimation, how the state looks like in the power substation. Maybe, for example, if there is no fire or there is no temperature high rising, and then it can give a false signal that, okay, suddenly temperature has been went to 100 degrees, and then please alert the fire signal or whatever, for example. And then this can happen by compromising different methods or sensors we have on this substation, for example. And then this will have a big issues in the smart distribution grid, because you will have alerts will be generated, and that may have to change some voltage regulation at some point and some instances. So this will impact the grid stability. Not necessarily this will create a blackout, but that may have some complications. Then we have a different smart grid components that may be needed for a smart distribution grid. And so these components, it's the same thing. I think this is with a different computer system, that there could be a malware which is delivered in the equipment from the vendor. So this could be a pre-installed malware, for example, assuming because we are running a critical infrastructure now, and that has to be protected. Same thing what we discussed with a mobile telecommunication environment in 5G, that some components may have a pre-installed malware, for example. And what if the attacker compromises vendor X and replaces the firmware on the PLC with Trojanized version, which we have seen already in some oil segments. Actually, in the oil industry, we have seen this kind of attacks, and this may also happen in future on smart grid components, that they can use this to destabilize the power grid, which may have an impact on the society, because some critical things will stop, or at least it will get delayed. Of course, they will have a backup, but this will have create some impact. So these kind of things we also already discussed, and with smart grid components. Then again, we try to also see that the software update, which can be also given to these malware components, they may have also a problem with those software update mechanisms. And this kind of classical attacks we already have been seen in the past. So usually the vendor use website to distribute software updates to customer, and these websites usually sometimes they have vulnerabilities that can be exploited by the attacker. And if your firmware is not being signed or patched by proper keys, and the key mechanism has not been properly followed, then it's possible to forge those signatures and try to modify the software and make it like a legitimate copy, but actually it will be a malware, which is basically with the update. And this may create some problem within the DSO network, and that may have an impact on the DSO network. This will have a problem with smart distribution grid. Then going with another thing we talk about in future we may have a system where control system, because nowadays people talking about not people, I mean academic researchers, also the industry is talking about how to use AI and machine learning in smart grid in future, because this will be more ICT components, OT technologies, there will be more data that needs to be processed effectively for automation, and artificial intelligence or machine learning things will be more important. But at the same time, you will be using some kind of an algorithm to train this normal data, and the same classical problem. I mean, attacker may try to learn those algorithms, and he tried to gain access to the communication channel or injects the commands. And the attacker goal would be just try to confuse the AI algorithms. Or confuse their patterns, actually, that okay, this looks like some kind of a variations, and try to create some kind of an alert based on the data. And this is also classical problem with what we have been many other researchers are looking into protecting artificial intelligence algorithms, like so that they should not be get attacked by modifying the data patterns just to confuse the algorithms what we're being used, because algorithms could be secret, but actually they can be learned by giving the test data and see what exactly happening at the decision making. So this has to be, this has a potential, but at the same time in future that can be misused by the attackers with machine learning abusing those algorithms. And we try to also take reference of those some of the attacks we have seen in this domain, and we try to reference them as well. And then come back to the microgrids, which is kind of an emerging trend. And of course, microgrids are more or less, actually, they rely on ICT resources for interconnecting different loads and distributed energy resources. And usually those resources could be computer connected with the internet, or IoT devices, actually, which are being connected over the internet, or it could be a local network. And attacker could try to make some attacks over their interface if they are using radio communication. And I mean, there are already we are seeing some use cases with 5G technologies, or even with the 4G we have, or people try to use Wi-Fi or Zigbee network, for example. And they could be possible that an attacker can try to do false data injection attacks within the microgrids, which will be, of course, attacker has to be local attacker. If he's doing over there attack, which means he has to be proximity within those IoT devices. He cannot be a remote attacker. But if they are being connected over the internet, different IoT devices, or with the cloud network connectivity, just to get the more data in the streamline, I mean, they can be attacked remotely over the internet. The second is about DOS attacks. I mean, all those ICT components are bound to happen DOS attack if it's not being monitored properly. And what we have been seeing, or what we will see in more future, that people will try to use more cloud computing or software-defined networking for operational technology or information technology within the smart grid components as well. And the problem is, of course, the requirement of interconnectivity within the microgrids is absolute necessary, and this interconnection can be attacked for making denial of service attacks. And examples we try to give them: attacker can get access to the wired or wireless communication channel to either intercept or modify the data. At the same time, compromised sensor IT systems can be used to send false data to connected device. This is just example we gave for false injection, but for DOS attack, there could be similar examples. Either you try to install a malware, which may not be doing fancy stuff, but he's just trying to make a denial of service attack, not getting access, not disconnecting the components, sending data, for example. And what could be learning from those misuse case scenario? I mean, I just try to give some examples of primary misuse cases. But what we've been intention was, once we identify these potential misuse cases, and this will help us in identifying some security requirements for future smart grid. So when you want to deploy a smart grid architecture, then you need to consider at least what kind of security requirements you can make out of these misuse cases. And your system needs to fulfill these security requirements before the deployment. And by doing so, of course, you can try to reduce the associated cyber risk. Of course, you need to also, at the same time, do a threat risk assessment. And this could be one part of a risk assessment at the same time, identifying misuse cases and potential impact on the system, or which components are getting affected. And that will help to reduce the cyber attacks. At least that will be, I would say, a more proactive approach to reduce the cyber risk. At the same time, we believe that the misuse cases, what we have been presented through this research paper, they will assist in development of new cybersecurity mechanisms for the next generation power grid, and basically what we have been talking nowadays about digitally connected smart grid, self-filling, automation characteristics. But I mean, all these three components, if you wanted to add to the smart grid components, I mean, you need to have some kind of cybersecurity mechanisms for them. And of course, you need to think of the worst case, what can go wrong and what will be having the huge impact, assuming all this technological feature you wanted to use it. And we believe that what we have been presented so far, that can contribute in this direction to identify the security requirements. But also the list what we have been presented is not being exhaustive. I mean, there could be much more that we haven't been covered so far, because we only look at the three aspects so far, or three categories of misuse cases, but there could be other areas which we haven't explored. So in future, we plan to intend to focus on other areas where we can try to think of misuse cases before we proper risk assessment of smart grid systems. So that's the takeaway from our message, and I think we have 4 to 5 minutes for questions and answers. Thank you.
Thank you, Ravi. That was really good presentation. So we would be able to squeeze in 1 or 2 questions. So I will look at the Q&A. Okay, one question for you is, have you considered, or is it possible to have, since you have the interconnected grid on IT systems, do you think there will be a use case scenario where you have crossover malware from IT affecting OT? What are your thoughts?
Yeah, that's definitely possible, because I think that the line between OT and IT is getting reduced nowadays. I mean, there used to be quite not logical, but separation, at least that those systems would not interact with each other. But nowadays we want it to be, don't want any latency in terms of response, what you want with the data. So we want as soon as possible. So actually, there is no physical separation kind of used to have in the past, and in future I think we believe that this will get less and less. Of course, maybe our OT technology get much more cybersecurity perspective, so maybe we will have a less impact, but definitely we're going to cross OT and IT on that channel as well.
Okay, thank you. We haven't got another question for you, and we have to join the next session. So thank you, Ravi, and the team for presenting your work.